Today, we will learn about the comparison test. Comparison tests are used to determine the convergence or divergence of the series, rather than evaluate the sum when the series converges. It's like integral test. We just determine whether the given series converges or diverges rather than evaluating. Let's review with the prerequisite material. Evaluate the limit if it exists. The first problem is limit t goes to -7, t squared minus 49 over 2t squared plus 15t plus 7. If you try to evaluate directly, the first thing you notice easily is if you plug that number into here, then the numerator will become 0. And when you do the same thing to the denominator, you will end up getting 0. So this is 0 over 0 form, but both numerator and denominator are quadratic equation. So we wanna factor. The first thing you learned in college algebra was a squared minus b squared is a minus b times a plus b. So when we factor the numerator, that goes like t squared minus 7 squared. So we can factor that into t minus 7 times t plus 7. And if you factor this one, then that is 1 times 2 and 7 times 1. When we cross multiply, this will make 14 and this one will make 1. And so when we add them up, we get 15 here, the same as this one. So this is the correct factorization. So after we do this, we just add t, the multiply by t and add. So factoring goes like t plus 7 times 2t plus 1. You can use any factoring method you like. So limit t goes to -7. We have t squared minus 49 over 2t squared plus 15t plus 7. So that equals limit t goes to -7. The numerator is t minus 7 times t plus 7. The denominator is t plus 7 times 2t plus 1. So numerator and denominator contains t plus 7. So when we think about limit t goes to -7, the numerator is t minus 7 and denominator is 2t plus 1. And then we realize that the denominator is not 0 and we can get a valid number. So if you plug in -7, then -7 minus 7 over 2 times -7 plus 1. So numerator becomes -14 and denominator becomes -13 because this is -14 plus 1. So that becomes 14 over 13. The next problem is limit t goes to -4, x plus 4 over x cubed plus 64. When we plug in -4 to the numerator and denominator, we have the same pattern. We will get 0 over 0. So we have to think about factoring first, and we have to simplify first, and then we will go from there. There is a formula for the denominator you learned in intermediate algebra. X cubed plus a cubed is x plus a times x squared minus ax plus a squared. So when we consider t goes to -4, the numerator is x plus 4 and denominator will be x plus 4 times x squared minus 4x plus a squared, which is 4 squared. So we realize that these are common factor. So all we have to do is we have to evaluate the limit t goes to -4 x squared minus 4x plus 16. So we plug in t equals -4, then x is -4 squared minus 4 times x is -4 plus 16. So that becomes 1 over 16 plus 16 plus 16, which is 1 over 48. What we have been doing is evaluating the limit, and those limit values are actual limit value. The next problem is limit x goes to -7, 1 over 7 plus 1 over x over 7 plus x. So then that is limit x goes to -7 and the denominator is 7 plus x. Then we consider the common denominator. The denominator is 7x, and so we cross multiply, then x plus 7. So that can be written differently. X goes to -7, and this is the numerator, which is x plus 7 over 7x times the denominator can be multiplied by 1 over. So 1 over 7 plus x. And those two factors are common, so they will cancel each other. And we end up getting limit x goes to -7, 1 over 7x. So we have 1 over -49. Any question? So those are just a warm up. And the first key theorem in this section is the limit comparison test. Limit comparison test compares two series. One of the series convergence result is known. And based on that, we want to determine other series convergence. So both are series with positive terms. Let's say limit an over bn equals number c, where the c is a finite number and c is positive. So positive and finite number. Then either both series converge or both diverge. So that is the content of the limit comparison test. So we think about the ratio of each term in the series, and if limit goes to a finite positive number, and then both converges or both diverges. Let's do some examples. Test the series for convergence or divergence. So first one is summation n equals 1 to infinity, 6 over square root of n squared plus 6. When you do this type of problem, what you will do will be just remove all the terms which are not really contributing to this sequence grow or decrease. So that means we just think about the largest growing term in the numerator and denominator. So let's let the given series term be denoted as an, and then that becomes 6 over n square root of n squared plus 6. And the other sequence we want to compose to compare will be 6 is a finite number. The simplest finite number is just 1, and over, we just forget this 6 here, and then square root of n squared will make n. So bn is 1 over n. So when we think about limit n goes to infinity, an over bn will be limit n goes to infinity, an times 1 over bn. So we have limit n goes to infinity, an is 6 over square root of n squared plus 6 times 1 over bn is the n over 1. Because that is the reciprocal of bn. And then it becomes limit n goes to infinity, 6n over square root of n squared plus 6, right? And then the method I taught to you was we just think about the highest growing term in the numerator and denominator. Then the numerator becomes 6n, and the denominator becomes square root of n squared. Then that becomes limit n goes to infinity, 6n over n. So these two will cancel each other, and so that becomes 6. In the limit comparison test, what it says is when we compare the two sequence and think about the ratio, limit of the ratio, if that limit converges to a finite positive number, then both converges or both diverges, right? So the sequence we were thinking about was a harmonic, will make a harmonic series, right? Since harmonic series n equals 1 to infinity, 1 over n diverges. Summation n equals 1 to infinity, 6 over square root of n squared plus 6 diverges by the limit comparison test.
Hold on, which aspect of the test did it fail that it diverged? Because I thought we ended up with a
No,
positive constant.
it doesn't fail. What we are saying is when we compare two series, term of two series, and if we think about the limit of the ratio, and both are the limit is finite and positive number, then either both converges or both diverges. And so what we know when we pick 1 over n, we know that harmonic series diverges, right? And so when the ratio become a finite number, then that implies this one also diverges. So what cannot happen when the limit of the ratio become finite is this diverges and this converges, right? And so basically those are just same kind. And when we just think about convergence or divergence.
Gotcha.
Any other question? The second question is n equals 1 to infinity, 4 plus 3n over 4 plus n squared cubed. So again, we will form two sequence, just the given one is more complicated, 4 plus 3n over 4 plus n squared cubed. And what should we do? So Bn. So the other sequence we will choose will be relatively simpler. We will just simplify the circumstance from the given one. So the fundamental technique to do it is just like just to think about the simpler version of this one by forgetting just a slower growing terms in the numerator and denominator. And when we think about the convergence of series, 3 times something doesn't affect the convergence or divergence. And so we will just put n here. And when we think about the denominator, we can just expand those, but in the end, what we will choose will be the highest growing term. So all we have to care about is the highest growing term, which is n squared cubed, right? So we get n over n to the 6th power. So that is 1 over n to the 5th power. So what you can imagine is if the ratio becomes finite number, then this converges, series formed from this one will converge. So series formed by this one will converge. So this one will converge, right? But we have to calculate limit n goes to infinity, an over bn equals limit n goes to infinity, an is 4 plus 3n over 4 plus n squared cubed times 1 over bn. So we think about the reciprocal. So when we think about multiplying all those, so 4 plus 3n times n to the 5th power over 4 plus n squared cubed. Again, we are thinking about the limit. The slower growing terms in the denominator and numerator will not affect the limit. So the highest growing term in the denominator is n squared cubed, and the highest growing term in the numerator will come from here. So 3n times n to the 5th power. So that is limit n goes to infinity, 3n to the 6th power over n to the 6th power. And so that is 3, which is greater than 0. And finite. So that means both converges or both diverges. So by P-series test means if this power is greater than 1, then 1 over that power, n to the p power, summation of 1 over n to the p power will converge. So this one is greater than 1, so summation n equals 1 to infinity, 1 over n to the 5th power is a convergent series. So therefore, summation n equals 1 to infinity, 4 plus 3n over 4 plus n squared cubed converges by the limit comparison test. Any question? There are some other patterns of examples. If you open the lecture note, but those are pretty similar questions. So as you know, the next week you will take an exam. The exam range is chapter 10, section 3 to 4, and chapter 11, section 11.1 to 4. Okay, so this section will be included in the exam. The last topic I have to cover in this section is the comparison test. So comparison tests also compare two series, AN and BN. Those are series with positive terms. The first statement is if summation Bn is convergent. And the other sequence is smaller than Bn for all n, then summation An is also convergent. The second statement is if summation Bn is divergent and sequence An is greater than or equal to Bn for all n, then summation An is divergent. So this is pretty common sense. If two sequences are positive sequence and we form series, and the one sequence is smaller than the convergent sequence, then of course when we add them up, this one should also converge, right? And if each term is larger than divergent sequence, then when we form the series, if the smaller one diverges and then larger one also diverges, that is comparison test. So determine whether the series converges or diverges. So the first one is summation n equals 1 to infinity n over 5n cubed plus 6. You can still with the work with limit comparison test to think about this, and then obviously the limit will be finite positive number, and so both will converge. But we will use comparison tests. In this case, what we will do will be, we will compare the given series whose term is defined as n over 5n cubed plus 6 with n over 5n cubed. Again, I just focus on the largest growing term on the numerator and denominator. And then that becomes 1 over 5n squared. And so we can say that that is less than 1 over n squared for n greater than or equal to 1. So by p-series test, we know that n equals 1 to infinity, 1 over n squared converges. So now we are using the comparison test. So by the comparison test, summation n equals 1 to infinity, 1 over n squared converges. Any question? The next one is a summation n equals 1 to infinity, arctangent of 6n over n to the 2.1 power. So in this question, we have arctangent 6n, so the problem looks a little bit strange. And we have to think about the graphical shape of the tangent function. It looks like this. This is negative pi over 2, and this is pi over 2. And this is the graph of y equals tangent of x. So when n gets larger and larger, it diverges to infinity, and its inverse value approaches pi over 2. However, it doesn't become pi over 2, and it doesn't become larger than pi over 2. So this is the last section in the exam range. I'm still covering the exam range. But the last section is not difficult section as long as you just understand the statement. So what we can say about arctangent is arctangent of 6n So we are thinking about the inverse image that is less than pi over 2. So arctangent of 6n over n to the 2.1 is less than pi over 2 over n to the 2.1. So it can be rewritten as pi over 2 times 1 over n to the 2.1. So we have to think about the series n equals 1 to infinity, pi over 2, 1 over n to the 2.1. So we realize that this is a p series because 2.1 is greater than 1. So as a p series, this converges. And then what we showed was this each term is greater than 0 because n starts from 1. So somewhere here, and the inverse image stays positive. So it satisfies the condition in the comparison test. So by the comparison test, summation n equals 1 to infinity, arc tangent of 6n over n to the 2.1 converges. Any question? Let's do the next problem. Summation n equals 1 to infinity, 7 to the n plus 1 over 6 to the n minus 5. So what we want to do is we want to compare this term 7 to the 7 to the n plus 1 power over 6 to the n minus 5 with 7 to the n plus 1 over 6 to the n. So obviously this is negative and minus 5 in the denominator. So this is smaller than 6n. That means that the fraction on the left side is bigger than what's on the right side. So that can be written as 7 times 7 over 6 to the n power. And that is even bigger than 7 over 6 to the n power. So we have to think about summation n equals 1 to infinity, 7 over 6 to the n power. And then we realize that this is a geometric series with ratio greater than 1. So that diverges. As I said, that's because absolute value of r equals 7 over 6, which is greater than 1. Therefore, by the comparison test, summation n equals 1 to infinity, 7 to the n plus 1 power over 6 to the n power minus 5 diverges. Any question? Others are pretty similar. Let's do just one more problem. We have summation n equals 1 to infinity, n plus 8 over n times square root of n. We want to compare with something, so we are having the same strategy. We just think about the highest growing term in the denominator and numerator. Then we will get n over n square root of n. And obviously plus 8 on the numerator will make the fraction larger. And so fraction on the left side is bigger than the fraction on the right side. And when we simplify, that'll be 1 over square root of n. So we apply the P series. So by P series test, summation n equals 1 to infinity, 1 over square root of n diverges. So by the comparison test, summation n equals 1 to infinity, n plus 8 over n square root of n diverges. Any question? Hopefully you will be well prepared for the next exam and do better and better until the final exam. So see you on Monday, so on the exam day.